Hello, good day. Today we'll be looking at the auxiliary plan of a square based pyramid. Although we've done some drawings on this, I just want us to get a hold of the concept. Just to get a hold of the concept. That's why it's very important that we get a hold of this concept and of course the numbering system. Alright, so whenever we are given something like this, of course the task to look out for are first the angle of observation that the viewer observe the given object on. Of course this is a square based pyramid. Of course we know that based on the direction of the plan view or what we've been told. It's a square based pyramid. Of course you know that a square based pyramid has this apex and they all meet. Of course it has these diagonals and they all meet at the apex. Alright, so the naming next is for us to look out for to name the object. It's very simple naming the object. I have my alphabet already, so I'm naming this side A. Of course this is your plan A. I'm naming here B. As I usually say, it's however you want to name yours, it's left to you. Name this other side C. Of course I'm naming this side D. Remember this is the plan view, and since it's the plan view you can see all the object, all the sides of the object from the plan, so you know what you are naming, you know what you are actually looking at. All right, the next one is of course to name the alternative elevation. Because this is a plan, this is the elevation because it's in first angle projection. In first angle projection, the elevation is always above the plan. All right, so alternatively we are naming this A because this point is A. This is it. The face of the drawing is A, and then we have, okay, I'm naming that A dash is B dash because this is this point here, B dash, and of course C dash is at the back there, though you can't see it from this front view, but from the plan you can see that's where C is, so it's just behind up there. And of course D dash as well. D dash, you can't see it from the front elevation here, but we can see it from the plan, so it's just there, we know that it's there. All right, so having done that, of course the next thing we have to do is to get the width of this elevation. We have to get the width. Since we are asked to draw the auxiliary plan, I forgot to mention, whenever we are asked to draw the auxiliary plan, of course our projections come from the orthographic elevation. That's why the arrow is there. And whenever we are asked to draw the auxiliary elevation, our projections usually come from the plan. So everything we are doing for this now, when we are asked to draw the auxiliary elevation, we will do for the elevation side. I hope you understand what I'm trying to say. For example, if you are asked to draw the auxiliary elevation, so of course our projections will come from the plan, and then of course our width will be gotten from the elevation itself. Now we are asked to draw the auxiliary plan, so our projections are coming from the elevation and our width is coming from the plan. Okay, so you got to get that fixed in your heart. All right, so the next, I said we are getting the width as well. I've already set my drawings. Of course with your divider you have to get all the points of the width, all the points where there are joints. So there are only 3 joints here, 1, 2 and 3. Getting all the points from all the width. So just draw an extension line as well. Draw an extension line from there. Of course, the last one we draw an extension line from point A. Alright, so that actually solves our problem. So those extension lines act as the scale on which we are going to get our width from. Of course, after you've done that, you have to draw a vertical line passing through all of them right there. Alright, so let me just pull up my vertical line. Okay, one of my vertical line right now should be a perpendicular line. That means it should be very straight. In fact, it should just be perpendicular. That's just that means. Alright, so with that perpendicular line, I have my width actually set up. That's quite very simple. Of course, I'm gonna give it I'll give it names. So I'll call this my 1. I'll call that my 1. I'll call this my 2. Of course, I'll call this my 3. So all these things are actually very, very important. Oh, sorry, that's my 3. Okay, so all these are very, very important and vital to getting it right. That's based on auxiliary projections. It might seem confusing at first, but when you get used to it, it solves a lot of problem, and it reduces your time in the exams hall of getting confused based on steps. Alright, having actually done this, of course, you see this is my point 1. That means CD lie on 1, AB lies on 3, and of course this point, let's call it point 0, lies on 2. Let's call it point 0. Call it point 0. Call it 0. Okay, that's the apex of that's the apex or the vertex, so we'll call it 0. Let me take it out. Alright, so that's 0. That's the apex here. That's at 0. And then of course we have A, B, C, D. Just as I said, CD lies on 1, 0 now lies as the apex lies on 2, and of course AB lies on 3. I can invert this. Let me just invert this. You know why I'm doing this, so you can do yours just the way that you understand it. There's no problem about that. I'm doing this because I like starting from 1. Alright, okay. Having done that, the next is to actually produce our projections. Remember, whenever we're asked to draw auxiliary plan, our projections usually come from the elevation. So next we are to actually pull off our projections. Projections should be parallel to this arrow. That's the angle of view. It might be 40, 45 degrees, it might be 60, it might be 70, whatever angle has been given. That should be the angle on which you draw your projections. So you get your protractor, get the angle right, and of course measure out the angle, and of course produce your projections. They should be parallel to this line. Very important. Alright, so I have my lines set and ready. So I'll start drawing my projections, starting from A, of course B, and of course point 0, the apex. So it's got the projections should come from all the it should come from all the joints of the drawing. We have only three joints in any triangle, so it's 1 2 3. To be a square, that means it will be 4 joints. You understand? So that's all. That's all. If it to be a hexagon, of course, you know hexagon is 6, so it will be 6 points that you'll be pulling these projections from. So we have only 3 here, so it's 3 joints. So having done that, of course, the next thing you have to do is to produce a perpendicular line passing through these projections. You know what a perpendicular line is? Okay, so I'm drawing my perpendicular line, actually passing through as a perpendicular line. So it's a 90-degree line to any given line. Of course, I'll call that my new x1 y1. So I didn't actually name the xy line here, but of course I'm sure you understand what I'm referring to. So I'll call it x1 y1. Alright, so next we have to get the width. This width, that's the width, the distance from here to here. We have to place them along any of the edges of the projections, along this projection, either on the lower side or the top side, any of them. Just to project your width there, or with your divider, measure the distance, 3 to 2, place it here, 2 to 1, place it here. That's quite very simple. Alright, so we transfer the width to this side, so you can see the length of 3 to 2 is the same from here to here. The length from 2 to 1 is the same from here to here. That's 2 to 1. Alright, having done that, of course, the next thing we have to do is to draw perpendicular lines across the projections that we got before. So that should be quite easy. So you get projection lines. Actually, this one is already drawn. So of course, from point 2 to get another line running across, should be a perpendicular line as well, or a line parallel to xy. Should be a line parallel to xy. So of course it will turn out to be a perpendicular line. Of course, having done that, quite simply, the next thing we have to do, because we are almost done, next thing we have to do is one of the most important facts, is the most important in auxiliary projection. So we are simply to locate the point. It's usually quite confusing for students, but then I'm sure with these steps it's quite easy. Right, so to do that, of course, you have to draw your simple vertical lines to meet any of the joints. The joint, just as I'm drawing from D, from, of course, from D there up to the elevation. Just draw straight lines from there up to the elevation. So what this means is that we are taking the projections from here, running them up and aligning them here, locating the joints here. So this is from A. We are starting from A. We are running up from A, where we meet A here. Of course, that's where A is, right in front of us there. We are coming down, and notice A, B, they all lie on 1. 0 lies on 2, and CD lies on 3. So we proceed. On 1 we have A, so we are following A up to A dash. From A dash we are coming down to 1. You can see 1 there. So where this A dash line crosses 1, that's where we are to place our point. That's our first point, A. Alright, so I've easily marked my point A1 there. Alright, move over to B. B is also on line 1. So we follow the line up to where B dash is, and we go down, and of course, let's say B is on 1. This is our line 1. So on 1 we have to mark that as a B1. Alright, so quite simply mark your B1 right there. Alright, the next thing we are going to see So C is now on line 3, not on line 1 anymore. C is on line 3. So you move up where this hits. You know that C is just behind there, so these are C also. And we're moving down to line 3, remember. So that's our line 3, and that's where C1 is. So I'm moving, you see I set up my C already. So that's my point C1. All right, move over to point D. Of course, D is also on line 3. So you move up where where you hit the BD point, because that's B dash D dash. Where you hit B dash D dash, of course, you know that's where our D is to move over, and of course we say D is on 3. D is on 3. So where D hits point 3, we have to place our mark right there. All right, so we are almost done. The next thing is point 2. That's point 0, and of course we said point 0 lies on line 2. Remember, point 0 lies on line 2. If we extend it, I'll just say it hit point 0. So point 0 lies on line 2. So that's our line, the middle line. It goes up to where the apex is. It goes up to where the apex is. Of course, when you hit the apex, you come down, and we are saying it's line on point 2. 0 lies on point 2. Of course, that's just the only line on point 2. Of course, that marks our point 0. I didn't actually set that up, but of course that's just what it refers to, so I can even set it up quite easily there. Right, so that's our point 0. Of course, I can color it whatever I like, just for identification purposes. Right, so our point 0 is just there. All right, so of course that's 0 1. Okay, I won't do that now. All right, so the next is for us to locate our joints. To locate our joint, and of course the plan helps us do that. A goes to 0. These are A1. See, A goes to 0 there, because that's also a 0 on top there. So A goes to 0. So with your ruler and your pencil, of course, you draw a line. A goes to 0. A goes to 0. That's all. Move over to B. B goes to 0. You can see the line B goes to 0. So B, where is our B? Okay, that's our B. Our B goes to 0 as well. Alright, what of C? C, where does it go? It goes to 0. They are all going to 0. I wonder what's happening there. Okay. Maybe it's New Dubai. Alright. Now of course D also goes to 0. Okay. That's quite simple. Everybody's going to 0. Okay, sorry about my sniffles. Alright. So everybody goes to 0, and that's just our projection right there. Of course, that brings us to the end of the lesson. Of course, you know you have to outline all your drawings to show us the beauty of your work. It's essential you outline them all. Of course, for that, and then which other one? Okay, that's for D0, A0, and of course B0. Right, so of course we have to outline the base line there. Of course, we actually need a new line. Okay, there. So we are just okay, so we have our auxiliary plan of a square-based pyramid. Of course, that's what it looked like. That's what it actually looks like, and that of course is your answer. Of course, I'll need you to go over it, get the steps correctly, and of course you see that you actually have your drawing quite there and quite simple. All right, so thank you so much, and of course, bye bye.